Hi, good morning everyone. Can you hear me? Is uh, is my voice audible to you? Are you able to hear me? So there will be a questions window. You can type anything in that to communicate with me. Okay. Can you hear me? Hi. Hi Samant, hi Subha, hi Shrikant, hi Srinivas, hi Vidyananda. If you can hear me, then you can actually respond by typing in the questions window. Okay, good. Good. So you are able to hear me? Good. All right. So good that we have only few members today. Probably there'll be more joining in some time, but we'll get enough time. So why don't we start with your introductions and then we go forward. You can just write in the QA window and a little bit about yourself and okay. And what are you looking for and what is your background? Okay. So Samant is a Java developer and curious to know what is big data. Good. You are at the right place. This is Srinivas. Okay, so Srinivas is working on developing machine learning algorithms for object detection. Great, great to know you, Srinivas. So this session may not give you the deep insights into machine learning, but will give you the basics overview of big data and Hadoop. All right. So if that is the thing you're looking for, okay. So yes. So because in machine learning, the big data plays a major role because you get to churn a lot of data and hence better learning. So definitely big data is going to help you. Okay. So please feel free to introduce yourself by while others are joining. Hi Shrikant. Shrikant has 3 years of experience in IT and IL, I think, and working as a QA. I'm looking to get some knowledge on big data. Good to have you in this session. You definitely will understand the basics of the big data and Hadoop, from which you can go forward and then you can decide. All right. So feel free to introduce yourself as you are joining in. Okay. So should we start? Okay. So hi Shobha. Shobha is working on Java J2E and working on few analytics project and looking forward to learn big data. Great. Great. All right. So let's jump in. Good. Now that generally these sessions, these free sessions have more than 70 people in these classes, but today we have few attendees. So we are happy to have. We'll be able to discuss more questions from your side. All right. Hi Vidyanand. Vidyanand is working as a reporting analyst and interested in learning big data and Hadoop. Good. Good. All right. So hi, I am Sandeep Giri, and this whole session is being organized by our associate Kelly Thomas. Okay. So hi Senthil. Senthil has 9 years of experience in IT and telecommunication domain. Interested in learning. Great, great. So great. I think it's a very smart move if you are planning to move into big data from your kind of background. All right. So first of all, welcome to the session and welcome from No Big Data. No Big Data is a big data knowledge platform where we provide instructor-led training, specifically instructor-led trainings and all the tools and techniques required for learning big data. Okay, so the few of the highlights about No Big Data is we have got expert instructors. These are industry experts. And the second is that we provide something called Cloud Labs so that you don't have to install any tools on your machine. This is how it happens in various organizations in the real life. So we give you that kind of experience in working on big data tools. Generally, traditionally people had been providing virtual machines, but virtual machines, running a virtual machine and working on it is a little more computationally intensive, meaning it consumes more of your computational, and your laptop may not or desktop may not support it. Therefore, we set up something called Cloud Labs. And using Cloud Labs, you can connect from office, home, anywhere, and still start start working on all of the tools immediately. Okay. So the other benefit of having a Cloud Lab is because it has around around 5 to 6 computers installed. having Hadoop and all of these tools. So you get to learn how do the big data tool works, because most of the big data tools are about distributed computing. Okay, we'll go into the details of each and everything, so nothing to worry. Then there is something called learning management system. We provide lifetime access to learning management system. And then if you are really performing great in our sessions, then we provide you a real life project. Okay, real life project requires a lot of commitment. So based on your commitment level only, we provide the real life project. Okay, so and there is a certificate we provide, which is a accepted certificate by various people. And we also keep the candidates connected with us by the way of having various alumni forums, so that our students are always connected with us. So we keep on sending them jobs, and because we have knowledge partnership with various organizations, so we could keep on sending new sessions, new content, so that they are our students are always updated with the new technologies. Okay, so hi from my side. I'm Sandeep Giri. I did my graduation from IIT Roorkee in 2002. Afterwards, I worked in a company called DE Shaw. This was a very interesting place. DE Shaw was an interesting company. We worked on big data ahead of our times, meaning we were churning tens of terabytes, not hundreds of terabytes. We were churning 10 or tens of terabytes, and that too in 2002. So we had around 11,000 nodes cluster on which we churned a lot of data. So afterwards, I started a company called Tbits Global. It was a document management system similar to what you have MongoDB or Documentum on large scale. And afterwards, I joined InMobi and Amazon. At both the places, I worked on things related to big data only. And in last year April, I started No Big Data. All right. So so today we are going to discuss first what is exactly is big data, how do you classify and characterize, and then we are going to discuss the basics of HDFS. So most of your questions related to big data should be answered in this session itself. Okay. So what exactly do you understand by big data? Let me start it from you. Yes. Processing very large amounts of data. That was Srinivas. Karthik says petabyte of data. And Simon says deal with large amounts of data. Okay. Okay. All right. And all right. So Samant says that deal with large amount of data. Data will be in various RDBMS. Okay. Vidyanand says that handle huge data with different format efficiently. It's a huge amount of data that a single computer cannot handle. Excellent, excellent. And Karthik says that huge amounts of unstructured data. Great. And Santhil says big data can be two kinds. One is quantity wise big, another quality wise big. So both is big data. Good, good, very brilliant question answers. All right. So let me summarize it for you. In very, very simple words, a big data is nothing but data of very big size. How big a size? That you cannot process with your usual tools. And to process such kind of data, you require the tools which are based on distributed architecture. What does it mean by distributed architecture? Something that runs on multiple computers simultaneously to solve a problem. Okay. To answer your question, the computation is being run on multitude of computers at the same time. Okay. So that is what is called distributed architecture. Data could be of any form, structured or unstructured. So out of all these 4 points, the point which is most relevant is distributed architecture is required. So so whenever you encounter a problem, when you require a distributed architecture, you say that we are dealing with big data. Okay. And when we say big, big in terms of volume, big in terms of velocity, big in terms of variety, and big in terms of veracity. All right. So what exactly is big volume? Meaning when you have a lot of data sitting still in your data center, then we call that you have got big volume of data. In case your data accumulated is low, but total number of requests that are coming from users or total number of data transmission is very very high, is known as the velocity, right? The velocity. And big variety as in your data can be in any format. In 80s we only considered the data in terms of a tabular format, or 90s we always consider data in database format. And but these days you have data in enormous amount of formats. It can be in the format of a movie, it can be in the format of a photo, it can be a map, or it can be a lot of other formats. It can be XML, it can be a binary format. So there are hundreds of formats. So big in terms of variety is also something we consider as big data. Now the fourth one is veracity. Veracity is something which is a little new in this is IBM's definition. Okay, this is IBM's definition where they talk about veracity. Veracity means that by virtue of confusion, but because of the confusion and doubt that whether a piece of data can be dropped or should be kept, just because of this confusion, you have to retain the data until you clear the confusion. And because of that, you might end up having the big volume of data. Okay, so veracity is generally a reason for having a big volume. Okay, all right. So veracity is basically when say imagine this. So I'll just take one example of all four. So If you have got lot of files, say for example, imagine Facebook has got lot of photos which are already stored. They need to manage these photos, as well as they need to keep doing magic on top of photos, that is volume. Now when you are posting something or refreshing Facebook page, and every time there are pings going to Facebook asking if there is something new, notifications have been posted, that is velocity. Okay, because there is a lot of traffic, but this traffic is not necessarily generating the big volume of data. Also, the other example of velocity could be the say for example, we are having this conference right now. Now my voice and the video is going to a central point and is being distributed to you. Imagine you have been like thousands of people. Okay, thousands, they had there been thousands of audience. So the amount of data going to the server and being distributed is thousands, and there's a lot of speed that is going in, and the data is being pushed from the server. Although at the end of it, there is no volume generated unless all of us start recording. So the velocity is high, even though the volume is low. Now, third one is variety. There could be a scenario when volume is low and velocity is low, and still the data has got variety. And because of this variety, or because of any of these four reasons, your data become big, and hence it may not, a single computer may not be able to process it, and therefore you would require a big data tool. So let's take a case of variety. Imagine that you have to find the best route from from Bangalore to Delhi based on the map. Okay, this map contains everything. So although the map size, if you see in terms of various things, would be few GBs. Okay, so the volume is not too big. Few GBs is not too big. It can be stored in even a flash drive as of today. So say for example, let's say the map size is 20 GB. So 20 GB can fit in very well on almost every device. So volume is not too big. But as well as there is no velocity, the map is not being modified continuously. Okay, it is the format of maps which you need to churn, as well as when you have to process a map, you have to go through the nodes and try to figure it out. So all of this is because of the variety of the problems and variety of questions you are asking, and variety of the data, because of which your problem becomes difficult. And in this map, finding path in the map, you might have to use multiple computers at the same time if you want response in a reasonable time, right? And let me take a case of veracity in case of let me take an example of veracity. Imagine you had one set of temperature data as in the readings of temperature at various locations. So you have one data which is based on zip code, other data which is based on lat long, and then other set of data which is based on say the other location name of the places. Now you have three data the data sets, a huge ones. Imagine that these readings are per minute readings, and other one is per second, other, and the third one is maybe every 2 seconds. So so you have got three similar data sets. Right now you do not know which one to discard and which one to keep, which one is more reliable than other. right? So till the point you establish the reliability of the data, you are bound to keep all the three data sets intact on your file system, right? So combined with veracity combined with a big volume ends up as big data, right? So does it make sense to you? Are you with me? All right. So how does latency come into picture? Latency is the velocity part. All right. That is Karthik's question. All right. So what is unstructured data? So when you have data in which you know exactly which field represents what is the data type of the field, we call it structured data. So every data which is lying in your RDMS is is any data which is lying in RDBMS is a structured data. While there could be another data type in which you know the fields in a data set, you know the fields, but you don't know their data type. Okay. For example, CSV, okay, comma separated files, or maybe XML, or maybe some other format. So such format is known as semi-structured data, right? Now there could be a scenario where you know nothing about the data you are handling. Okay. You know nothing about the data you are handling. Maybe, for example, an Apache log, or maybe a binary file, maybe some other format. In all these formats, the important aspect is that you you may not know what is the how it is structured, what is the field. So every time you have to process unstructured data, you have to first understand it, you have to parse it, and only then you will be able to make sense out of it. So that is the difference between structured, unstructured, and semi-structured data. Make sense to you? No? Great, great. Now, so let me ask you a very simple question just to keep you awake. How many bytes are there in petabyte? Yes. Srinivas says 10 to the power 12. Srikant says 10 to the power 15. Karthik says 10 to the power 15. Great. And anybody else? Neeta says a lot. Neeta, you are being very political. Yes, Bharat? Rivas says 10 to the power 12. Rafa says 10 to the power 15. And okay, Raghavendra says 1024 terabyte. Raghavendra is being very precise. Great, great. So best way to answer it is like saying 1024 terabytes. All right. So in quickly, I'll say that these may close to 10 to the power 15 bytes is 1 petabyte. And the classic way to remember it is this table. A byte is basically 8 bits and it can store 256 states, right? Using 8 bits, if you have 8 fingers, till what number could you actually represent using these 8 fingers, right? That is that is that is the data you can store on 8 fingers. So a byte can store 256 states and a kilobyte is 1024 bytes and so on. Okay. So kilo, mega, giga, tera, peta, exa, zeta, iota. And the sequence, the next step is 1024 into the previous one. All right. So we talked about two things. First is what is big data? We said anything when you require a distributed computing, meaning you require multiple computers to solve your problem, is called big data. And then we talked about a petabyte data. A petabyte is 10 to the power 15 bytes. So my question to you is petabyte a big data? Do you think petabyte qualifies to be the big data? To store 1 petabyte data, you need 1024 hard disks, each having 1 terabyte of size. So do you think 1 petabyte data qualifies to be the big data? Or in other words, if you have to store 1 petabyte of data, do you think you would require a distributed architecture? Do you think you would require multitude of computers to solve the storage problem? Yes. Feel free to answer yes, no, or maybe politically correct answers. You. Yeah. Karthik says yes. Rafa says yes. Santhil says yes. Anybody else? All right. So everybody is agreeing that 1 petabyte data is a big data. Bharat says that Bharat says that petabyte is not a big data. Okay, this is interesting. And why do you say so? Give me a little bit of reasoning. Or let me ask you a counter question. How are you going to handle 1 petabyte data? Actually, I'll go through an exercise where we will realize that why do I say that 1 petabyte data is big data. All right, all right. And in case you have, if you can type it, it will be great. If you can justify your reasoning behind a petabyte not being big data. All right, it'll be great. Great. So my answer is that petabyte is a big data, Why? Because most of the existing systems, single systems, cannot handle a petabyte data, even for a simple storage. The first step in handling the data is you need to store it somewhere, right? So that's why even storing a petabyte data would require a distributed computing. All right. Now, and on the same context, what would be the size of the text downloaded from all of the internet? Can somebody answer quickly? The text of the whole internet. Yes? Anybody, any guesses will do. So what would be in your opinion the size of the text on all of the internet, on all of www, World Wide Web? Millions of petabyte. Okay. So it's actually half petabyte, right? It's actually half petabyte. It's around 500 something terabytes. So if you go to public data sets at Amazon, you'll say the corpus of the internet text. There you'll see it's 500 terabytes. All right. So actually petabyte is a big number. It's just that it is just two syllable word. That is why it sounds like a nice cute one, but it's actually a big data. All right. So here we have. So this is the classic chart which shows that how data has data has expanded, how the data generation has happened in past. Starting from left to right, at the leftmost it's 1986, and the rightmost is 2007. So do you see that there is a line 2002 here? This is the point where it's suddenly the digital data, this portion, the gray portion below, is the digital storage, while this portion above is the analog. So analog storage did not expand at all. It actually became smaller day by day. But digital storage suddenly started expanding in 2002, meaning more and more people started storing their digital data at the rate of the the amount of the expansion was humongous. It looks linear, but it is an exponential growth in the data. Okay, it looks linear, but it's an exponential growth. All right. So why did it happen in 2002? Why did it suddenly started expanding in 2002? The reasoning behind that is this: smart smartphone and connectivity, meaning hardware and connectivity. So every device manufacturer's objective has been to build devices which are cheaper, faster, and smaller. And that's when in 2002 we started having devices. Everybody started having good and enough computers, and we started having mobiles and smartphones, and that's when the data generation suddenly became too high. Okay, after some time everybody was having camera phones and clicking pictures, uploading them somewhere. So all of that started with the hardware, and the data got multiplied because of the internet. So if I say something, it is being sent to hundreds of people. I'm basically multiplying the data by factor of how many friends I have. And if it's really important, they will further multiply it, and that's why we call it exponential growth. Whenever you have this phenomena where the rate of change of something is directly proportional to the amount you have already, then it's called exponential growth. If you integrate this differential equation, the rate of change of the data is directly proportional to the data you have. If you integrate this equation, you get an exponential curve. All right. So that is one of the reasons the data expanded so dramatically. Connectivity multiplied the data, devices generated the data, right? Connectivity was, and when we say connectivity, it all starts with hardware. We had in 2002 itself, we started having a really great connectivity between people and between things. It starts with things, and then people built a softwares on top of it, like YouTube, Facebook, Twitter, and whatnot. And using that, they all continue to generate the data, right? So these are the two reasons: is devices and connectivity. Now, let me let's understand why do we require distributed computing? What is it that becomes bottleneck at one computer because of the big data? Okay, so inside a computer, you can vaguely categorize things into four. First is CPU, second is RAM, third is disk, and fourth is network, right? So you have got CPU, RAM, disk, and network. So whenever you want to store, say, 1 petabyte of data, okay, let's take one case each. Say you want to store 1 petabyte of data. Now, what will become bottleneck? Anybody? The disk is going to become the bottleneck, right? Perfect. Thank you, Rivas. First, disk size is going to become the bottleneck. Now, let's say you put this data onto multiple computers and in the network. So already you have opted for a distributed system. Now you want to process it. What is it that will become the bottleneck? Network will become the bottleneck. Thank you, Karthik. Yes. So if you put the data onto the network, then the network is going to become the bottleneck, right? So that is how the network is one of the counted as one of the processing units. Now let's take the second case of velocity. When the velocity keeps on growing, which out of these four become your bottleneck? Yes. Karthik says RAM. Good. Anybody else? And CPU. Yes. Right. So when the velocity is there, all three, CPU, RAM, and the network, all three will become your bottleneck. But out of all the three, the one which gets the bottleneck generally is your RAM. Every time a client connects to you, it either it's a process or a thread, but it would require extra amount of memory to be allocated to a client. And if more and more users are connecting to you, the RAM quickly becomes the bottleneck. Although these days you have started to get RAMs in hundreds of GBs, but RAM is still a big bottleneck as compared to the disk. All right. So as we saw that because of either of our problems, well, volume or velocity, some or the other aspect became the bottleneck. Okay, at least one of these become bottleneck when you process the big data. And after a point of time, if you start to get this RAM, so the way it happens is that when your RAM becomes a bottleneck, you try to flush the data into disk, and then you okay, so actually it happens the other way. When you launch your website, you are generally reading everything from the disk, and then you realize that I wish that we should be able to cache everything. So when we try to cache, the RAM becomes bottleneck, and that's when we say that we have no other option than moving to multiple computers so that we can have more RAM. Okay, or we try to scale it up vertically. All right, so that is the general aspect of the computing, and these are the four things which basically decide whether something can be processed on one computer or not. Now these are the few example data customers. Okay. Okay, so first and foremost is recommendation system. Recommendation system is probably the first example of what is a big data. Sorry, the first example of why did we need big data, or what could we do with big data, was recommendation engine. A recommendation could be an Amazon's you may also like it, or Netflix recommendation saying you may also like these. And recommendation could be of the form that when you are searching for something, you see the similar results in parallel, or when you search for something, the results itself are sort of recommendations. So recommendations are far more deep than what we think. All right, so you have the biggest use case of big data is probably the recommendation, and this is where the whole thing started. So why does big data matter to the recommendation? The answer is very very simple. If you have big data, you will get better recommendations. The quality as well as quantity of the recommendation is going to be great, right? If we have 200 people in a room and they are talking to each other and they are communicating that we like these, I like these movies, and then they're discovering movies, a better set of movies, it will be better if there are more people. If there are three people and then they are communicating, you might end up getting very few recommendations, and that too bad ones, right? Second is the search quality. Whether you are Google or you are an enterprise search company, like we had our document management system, in either of the cases, nobody can compromise on search quality as of today. Even if you have this recruitment management system or asset management system or library management system, everywhere you need to improve your searches. And even though the data you want to search is smaller, you still would require uh, sometimes you would still require churning the big data, right? For example, when you are type when you are when the user is typing a keyword, you might want to give him When the user is searching for something, you might want to give him the recommendations. And to give that recommendation, you might have to process a lot of data. Okay. For example, let's take a case of user is searching for a keyword called blue dart. Blue dart, right? Now, blue dart could be written in at least 10 ways. To understand in what all ways, in what all manner the user can search blue dart, you need to keep your dictionary ready. And to prepare this dictionary, you might have to crawl a lot of data from the internet in order to understand in what ways the people type blue dart, right? Yes, yes, Rafa, you're right. Okay, so search quality, even though you are processing a small data, need a lot of magic in place. Understanding what user is typing is one of the holy grails of searches. And to do that, you should have a great context about user and about the language which he's typing in and a huge dictionary of words. Third one is the sentiment analysis. Sentiment analysis in plain simple word means understanding the sentiments of people. And how can you understand the sentiments of people? Right? You use the social forums. For example, a Twitter, for example, various kinds of forums which are available across the globe. You use all of those in order to give to a sentiment analysis. Right? So for example, if you'd want to understand how was the feedback of Iron Man before and after the movie was released. So what will you do in this case is you will just download all the tweets from Twitter and then see whether people are talking positive or negative about your movie. And how do you compute positive and negative? You have a dictionary which tells whether a keyword is negative or positive. And using this dictionary, we compute whether each tweet is negative or positive, and afterwards we summarize everything and say that these tweets are positive, these are negative, and this is how the overall sentiment is going. So that is sentiment analysis. So to do sentiment analysis, you it only makes sense if you have big data in place. If you are churning date, if you are churning only 1,000 tweets, it does not make any sense. Reason why? Because if you have a very small data, you will end up having very bad results. Okay. So a bigger data, a huge amount of data, actually gives you a better insights. The computation of the overall statistics is better if you have bigger data. Then ad targeting. Ad targeting is my voice audible to everyone? Actually, Karthik is not able to hear. Okay. Let me just inform him. Okay. So in case any of you have a problem, try to. All right. Good. Great. Now, there are other use cases such as ad targeting, which are specific to advertising companies such as Google, InMobi, and others. Basically, when you have in an advertising company, what you have on one hand, you have advertisers, they give you ads. On the other hand, you have the real estate. which means the people who where you can display the mobiles on which you can display the ads. Now figuring out which ad to be shown where is actually a quite a difficult problem. You will have to understand each individual's context and give the results accordingly. All right. Now, other than that, you have various companies which are basically like telecommunication companies, which do a lot of customer churn prevention based on the past behavior of users before they leave you. So if you try to figure out if they are basically trying to figure out who how many times the user called, how many times his calls have been dropped in past few months, and what has been what has been his bill. So based on all of this, they are able to retain their customers by figuring out what exactly went wrong. And this all is possible by using big data technologies. Bigger the data, better are the results. Okay. The network performance optimization, such as the capacity management of the various network towers, and there are a lot of things telecommunication companies are doing in order to retain their customers, improve the experience of the customers, and all of this is easily done using big data. Example of ad targeting is something specific to Google and the ad targeting company. Okay, so when you see an ad on your mobile by playing games, it is being served by somebody, and there are people or thousands of people playing similar games. Now these ad companies need to basically do a lot of analysis of the user behavior in order to give the right ad, and that's where the big data comes into play. All right. Now these are few more examples of big data customers: government, healthcare, and life sciences. And this is a big slide. It's little, although it's little older, it shows how much people are using Hadoop, because if you have to gather statistics about big data, it will be difficult. And therefore, what I've done is, whosoever using how many instances of Hadoop is plotted on this chart. So the biggest one is Yahoo. Out of this, they have maximum number of instances, and the others are smaller. Okay. Now, these are the 11 common myths about big data. Good. So these are the common myths which people carry around. First one is big data always means data or above or in the range of terabyte. So that, as I gave an example of the map, searching a location in the map and the path from one point to another, even though the data was say 220 GB, still the problem became complicated. So the big data does not always means data in petabytes or terabytes. All right. Big data is always about social media. It doesn't apply to me. No. Yes. So the whole game started with social media because that's where the public data was available to the people. And but it doesn't stop there. Okay. Will replace enterprise data warehousing EDW? No. EDW has its own purpose. EDW is great for handling the structured data in smaller sizes. But EDW is not great when the data starts growing bigger and bigger. Right? Now, it is just a buzzword. It no practical implications. That's you know not correct. There are lot of applications I have already seen in my career. So this statement is only valid for those who haven't got into big data yet. Is a new concept? No. As I told you that in 2002 when I was working with DE Shaw, we were already working on tens of terabytes of data. Okay, we were processing that much of data parallelly on around 11,000 nodes. So it's not really a new concept. It is just popularized now by few companies because now it has become possible to churn a lot of public data. All right, it will be the future. No, it is the present. Is expensive? The answer is no. Okay, it all depends on how you're implementing. Almost all the big data solutions are free and open source. Hadoop is free and open source. All the tools which are from Apache with Apache license can actually be used in a professional environment without violating the license. All right. For example, Apache web server is actually used across the globe for everything, whether it's a profit for profit organization or non-profit organization, everybody uses that. So Apache license makes it possible to reduce the cost dramatically. And because of this Apache license, people like myself are able to you give training in that technology. Had it been something like SAP or something licensed one like Microsoft, I wouldn't be able to give the trainings because for few reasons. First, documentation will not be made available by these companies. Second, I'll have to pay to Microsoft and SAP for each and everything. So therefore, even the knowledge is not expensive. The only expensive is the mindset where people need to decide whether to move or not to move. Okay. It is only for data scientists. It doesn't apply to me. Okay. It or is as a magic. No. Data scientists across the globe are really doing a great job when it comes to say machine learning, AI, and statistics. They're doing a very brilliant job to give algorithms. An interesting part is most of these algorithms are available to most of the people. Okay. So those who are not great with the data sciences, they can use the algorithms provided by them. Okay. So it's not really for data scientists. There is a full ecosystem just like with every technology. Ninth point is we have enough of hardware, we don't need it anymore. Wrong. So it is not about hardware, it is about utilizing your even the existing hardware properly. Like for example, the whole big data thing started probably with Google trying to crawl the world, and they started acquiring smaller hard disks from their college mates. Okay, their old hard disks they started acquiring, and then using that they build a huge network of devices on which they stored the data. All right, the 10th point is most fatal out of it. We will build it when we need it. This is most fatal. Why? Because you cannot build it when you need it, because it's the other way around. Okay, say tomorrow you plan to move to big data and then you realize, oh, we don't have big data at all. So imagine you want to give an experience to the user based on his past interactions with you. Okay, his past interactions with your website, and you want to give a best experience, or you want to understand what went wrong with your users. And if you do not care to store their data, or if you did not care to store the debug logs of Apache, there is no point. There is no point of doing any insights. Okay, so unless and until you build an ecosystem in which you are able to store and compute, only then, after a point of time, you will reach to a point where you will be able to do a lot of churning, right? So basically, instead of having the attitude that we will build it when we need it, you need to start storing now. You need to give the comfort to your developers saying, hey, we have enough of storage. You can store your logs, your debug logs into this. Okay. So do not worry about storage because we have enough, and you don't need to drop any data. Earlier, we used to keep on dropping the data because we did not have space. Even if we did, the space was too costly. Therefore, the attitude that we will build it when we need it does not help you. It just puts you few years behind the industry. Big data is about Hadoop. No, Hadoop is just one solution. Big data is a general problem. Okay. Make sense to you? All right. So this is another slide with this all data shows that Gartner's in top 2014, all points are related to big data, that these are the technologies which have to come into place. Similarly, Forbes top 10 technology trends contains at least 4 points which are related to big data. And the same time, if you try to dig a little bit about jobs, you will find a lot of jobs on the big data and Hadoop. And on the right hand side, it shows a salary distribution. Basically, the most of the jobs in Hadoop and big data are in higher range of salaries. Okay, you can see it clearly in 6 to 10 lakh salary range. There are more Hadoop jobs than Java jobs, and further in 10 to 15, the ratio is still widened. Okay, but in the lower salary ranges, the total number of Hadoop jobs are smaller. All right. So this slide shows you why it is important for your career. Now, theoretically, what is Hadoop? Hadoop is was a project created by a person called Doug Cutting and Mike Caffarella. It was built for their personal project called Nudge. They were trying to build a search engine. Okay. It was named after the toy elephant of Doug Cutting's son. It is open source, and that is probably one of the reasons why Apache Hadoop has propagated so much, right? It is quite powerful and it is very well supported. And and basically, Hadoop is an umbrella of products. It started with two products called MapReduce and HDFS, but then it expanded to include lots and lots of projects under the umbrella. There are around 13 tools which are under the umbrella called Hadoop. Okay, so and all of these tools, they have a common property. These have to be reliable, scalable, and for distributed computing. Okay. So you can say that all the tools under Hadoop share a common property called reliable, scalable, and distributed for distributed computing. Reliable as in if something goes wrong, it should be able have a failover. First, it should not be corrupting the data. Second, scalable means that we can add more and more machines to the software, and it will still work fine. Okay. Distributed computing, as in it should be able to run on multiple computers at the same time. Hadoop was basically written in Java. The MapReduce and HDFS was written in Java, and the main reasoning for writing it in Java was that it has to run on almost all the hardware. Okay. Now, this is the slide which shows to you the various components of Hadoop, and the first component, HDFS, is what we are going to discuss today. Okay. The first component which we are going to discuss today is HDFS, and then we'll talk about other things. Okay. So, all right. So, do you guys want to take a break? Okay. So, some of you want to take a break. Let's take a break of say 5 minutes. Okay. Let's take a break of 5 minutes, and we will be coming back at 9:16 a.m. Okay. Let's make it 9:17. Hello. So I'm back. Are you guys back? All right. All right. So let's move on. All right. All right. Before we start with our Hadoop distributed file system, in this diagram, the one which is on which everybody is dependent is the file system. The file system where you store your data so that it can be interpreted by other systems. So whether it HBase or MapReduce, everybody is dependent on the file system. Flume and Scoop are import export tools. Flume is from unstructured data and Scoop is from structured data, while HBase stores billions of rows and billions of columns into the table and so on. So all of these tools are basically dependent on the file system. So we will start with the file system. What is so big deal about the file system? Let's start with the simple problem. Let me ask you a very simple question. If you have you have to store 100 terabyte of data, what kind of system will you build? How will you build 100 terabyte of storage? Okay, take your time, think about it. I'll wait for 1 minute and then we'll. Or again explain. Say you are living in a society, in a community, or in a place where all the people want to watch movies. They want to store at a central place, and there are, as per your computation, you require 100 terabyte of space to store the movies. Now your duty is to build such a system so that all of these people can watch movies and store movies onto the central system. How will you build such a system? Okay. Karthik says store in 100 computers with 1 terabyte each. Good, good. Distributed system. Yes. So we'll go to the distributed system later. Let's first try to understand. If you are supposed to build such a system, what will you build? And I mean, any ideas are great. So come up with something which you will use. Yes. So you are basically supposed to handle 100. This is a common problem, isn't it? One media server with lots of space, that is Rafe. But let me ask you this: how will you this media server? Can a single media server store 100 terabyte? And if yes, then do you see any bottlenecks with that? Read and write can be a bottleneck. That is Rafe. Anybody else? Yes, yes. So you will have to store in multiple computers, no central storage. That is Rivas. All right. Chaman says RAM, but RAM, I mean, RAM hardly is, even you don't have RAM beyond 100 GB, you know. Here we are talking about 100 terabyte. All right. The simple way, okay, okay. Samant mean to say that RAM will be an issue. Yes, yes. RAM will be an issue and read write both will be an issue because hard disk has a header. A hard disk has a physical movement when you try to access something. Good. All right. So the classic way we solved the problem was using a network attached storage or storage area network and building something of this sort. We bought 100 hard disks, each of 1 terabyte. Somebody like Karthik actually proposed that solution and attached all of these to a central storage. Attach these to multiple computers. And after you have attached them, you mounted them in a network. Mounting them in a network as in you basically made it possible for other people to access these hard disk via network. Okay. And each folder, we basically mapped one folder for each drive so that when the user comes to a machine, he sees a main folder and under which you'll see 100 folders for each of 100 drives. Right? Now, do you see any problem with this approach? So now we have 100 folders. We can store movies in these 100 folders. What is wrong with this? Do you see any problems? Anyone? Yes, network will be a bottleneck. Yes, and common folder is a bottleneck. Kind of, yes. Dependence, yes. Network dependence, yes, that is right. So network and common folder, and what else? How are you going to store the movies? Will you store all the movies starting with A in drive 1, all the movies starting with B in drive 2, and so on? Or you will approach this in a different manner? Carry on, right? Take your time. Do you see any problems with this approach? All we did is connected these hard disks, 100 hard disks into various computers and then mapped each of these hard disks to a folder and after you have mapped, this is how it is visible to your end user. When they open a computer, go to particular folder called network drives, they'll see these 100 drives as each one as a folder. Okay, Rivas says there has to be some form of replication in case one drive goes down. Good, good. Now, to answer to that one, let's assume that on each computer just below drive 1, just along with drive 2, along with drive 3, and so on, we have put, say, backup of drive 1, backup of drive 2 on the same computer so that when you're writing to drive 1 you are copying the data to another disk on the same computer so that in case drive 1 fails you have backup of drive 1 on the same computer. So do you think there is a problem with this approach? That's a very valid point. But let's say, assume that this is the form of replication I have provided to you. Do you think there is going to be any problem with it? Problem with this kind of architecture? Anyone? Disk space will be more, that is Vidyananda. Okay. Someone says the backup should be in another computer. Good, good. It should be in a different computer. Rivas says, what if the system goes down completely and accessibility is not there for those files? Yes. Hardware failed, then it's a problem. That is correct. What else? Do you see any other problems? Scalability issues. Yes. So if tomorrow if you have to move from 100 terabyte to 200 terabyte, then it is going to be a problem. Any other? All right. All right. So you guys have actually answered most of it. And here, these are the challenges in the previous approach. These are the challenges. First, what about failure, failover, and backup? Okay. In case one drive fails, can somebody else take up its place immediately? That is called failover. In case a drive fails, do we actually have at least one copy left? That is backup. Okay. What about distributing the data uniformly? As we said, if we are going to keep all the movies starting with A in drive 1, then your drive 1 is going to get filled very very soon, while the drives which have been allocated for the alphabet Q are just lying there without any data in them, right? So so the data distribution is not uniform. Okay. Is this best value for money? Is this best value for money? The answer is no. Why? Because we have bought the best hardware, 1 terabyte. We did not utilize we did not utilize the hard disk which we already might be having, the hardware which we already purchased, which we already have lying there. We did not utilize that. What about increasing accessibility? Now this was the answer somebody gave, that the network will be the issue and all of that. So imagine that there's a new movie that has come in and everybody wants to watch it, right? Since this movie is lying on one computer, everybody wants to watch this movie, and hence that particular computer will get overloaded and and afterwards will become unavailable due to too much of load, right? So that is what we call it increasing accessibility. Scalability, as somebody said, Apurv said, the scaling out will be another issue. Okay, scaling out, there are two ways of scalability. One is scaling up, other is scaling down. Scaling out. Scaling up means we remove 10 GB of RAM, we put more 20 GB RAM, and then we make RAM as 40 GB and we keep on increasing. That is called scaling up. Okay. Scaling out means we put another computer and having a similar kind of RAM, to solve our problem. That is scaling out. Okay, it's like, in case our cart, our our bull is having a difficulty with pulling the cart, we remove the bull and put an elephant which will pull the cart. This is called scaling up. In case we just add one more bull to the cart, that is called scalability, scaling out. Okay, that is called scaling out. Got the picture? Scaling out has various benefits. In case two bulls are not sufficing, you will add two more and it will become four. And in case an elephant is not sufficing for your cart, you cannot scale it further. We do not have dinosaurs available, right? Therefore, scaling up is not a solution. Scaling out is, in most of the loads. You got my point? So what is the solution then? The answer is use HDFS, Hadoop Distributed File System. Okay. Now we will go into the details of the design of HDFS and understand how does HDFS solve these problems which we have outlined above. So is this clear to everyone? Yes? Feel free to ask a question. The biggest advantage of these sessions is that you can ask a question and I'll try my best to answer. Great, great. So, eh, okay, so feel free to ask questions because that is what the objective of these sessions is. Okay. All right, so let's try to understand how is HDFS designed. So first and foremost, there are two kinds of nodes in HDFS. HDFS is made up of multiple computers. An HDFS cluster is made up of multiple computers. So one of these computers is called admin node. Okay. And when we say computers, it's computer is physical architecture. On each of these computers, we install a process. And this process is generally one of either it's admin node or data node. Okay. So one of the node we mark it as that this is our admin node. All right. And then rest of the nodes we mark them as data nodes. While admin node is like your register containing the information only, while the data nodes contain the actual data. Okay, so the admin node contain the references to where your data is actually located. Okay, so admin node is like as if it's a separate book containing the references of parts of the book. Okay, so in a library you have the catalog, and that catalog is basically the admin node here. Okay, so you will be storing your files in data nodes, and this information you will always get from admin node. All right, admin node keeps the most of its data into the memory, into the RAM, so that the response is pretty fast, and the data node actually store everything which you want to store. Okay, Vidyananda is asking that if I can explain the scalability once again. All right, all right. So imagine my idea was that, so when your let's say you have a cart in which there is a bull. Now instead of pulling 10 tons, you want to carry 20 tons now. Okay, you have two choices. One is replace the bull with an elephant. That is called scaling up. And the other choice you have is adding one more bull into the cart. That is called scaling out. Similarly, you are running a web server. Today, you are running it, and then your system is overloaded. Your RAM is about to get full. What you do is you add more RAM into it. Then we call it scaling up. And okay, in case we add one more computer, okay, in case we add one more computer and route some of the traffic to one node and some of the traffic to another, then it is called scaling out. All right, is that what you're looking for, Vidyanand and MJ? All right. So do we maintain admin node and data node in two different machines? That is Srikant's question. So the general idea is you should maintain admin node on data node on two different machines. All of the both admin node and data node is nothing but a process. But for example, uh, we ourselves keep the data node and admin node on the same machine because we think that we are just wasting our disk. But that's not a great idea. The way you choose these machines is data node is supposed to have huge disk space but not big RAM, while admin node is the machine having big RAM and small disk space. Okay, because admin node is going to keep everything into RAM while data nodes are going to store the actual data. Now, so this is the basic one. Now let's move on. When the next step is, instead of actually storing the full files, it goes one step further. It slices the files into smaller blocks. And the size of each block is 128 MB. If you want to churn the data, if you want to store the blocks, 128 MB, sorry, when you want to store a big file, it cuts those files into smaller pieces of 128 MB each and puts that into multiple data nodes. This way, you have got your data across multiple machines. Okay, and remember our problem where we were saying that uh, one the machines might be full, other might be empty. So that kind of problems are very well solved. Now you should note one thing: even though you have smaller hard disks of 100 GB, you can store 200 GB size file. How? Because 200 GB size will be sliced into small parts and will be distributed across the cluster. So you can have the smallest disk in your network equal to 128 MB, right? So that is the whole objective of slicing the file. It helps you fitting the big file into small disks, leaves less unused space on the disk, and optimizes the transfer. After a few points, you will realize that the data has to be transferred from one node to another for various reasons. And if there are these pieces, then it makes it more modular to transfer the data. It distributes the load to multiple machines. As we talked in the earlier session, when we were saying that in case there's a new movie release and everybody want to watch that movie, that problem is also solved because 1 GB movie, 1 GB size movie will have 8 blocks, which means eight machines simultaneously can cater to this data. Although it is not mandatory that all these blocks are stored on different machines. Okay, So you get the reasoning while files are split into the chunks. And 128 MB is just one number. Earlier it used to be 64 MB, but now it's 128 MB. All right. How can we communicate between nodes? I'll explain to you. Okay. Okay. Srikant's question, how we can communicate between nodes, we will talk about it. And just give me a minute. And Karthik says, does it mean that single movie is split and stored into multiple machines? Yes, you are right. Is this 128 MB hard coded? Will there be an overload of mapping these blocks? Good question, Poojan. So, no, 128 MB is not hard coded. When you are storing a disk, when you are storing a file onto the HDFS, you can say that you want a block size of 1000 MB. Alright, it is absolutely up to you. But in case you have smaller block sizes, then you will have too much of metadata, which means you are going to fill the RAM of your name node or admin node. Name node and admin node I'll be using interchangeably. You are going to fill your admin node very quickly, right? But in case you have a bigger size of block, then what will happen is the modularity is gone. No, it doesn't lead to any data loss at all. I'm trying to answer Karthik's question. That Karthik's question is, does it mean that single movie split and stored in multiple machines? Does it result in data loss? Answer is no, but the suspicion is correct. If you slice the data into small blocks, and in case one machine goes down that contains one block of all files, then all files are useless, right? Because you have lost one blocks of each file. So we'll talk about it in a minute. Okay. Yes, we can vary the size of block. You're right. All right. All right. So now the next one is replication. Okay. Next point is replication. Each block which we are putting onto the data node gets replicated onto other machines. And this replication happens from one data node to another data node. All right. This replication happens from one data node to another data node. So that the data, I'll talk about it a little while. So why do we need replication? As Karthik says that in case a block is lost, there is a chance there are huge data loss, right? So, and that's right, because you have sliced all of the files into small blocks. In case any of these blocks get lost, your file is lost, right? So the probability of failure has become bigger when you have these blocks, right? So to avoid that, it provides you with the replication factor. Replication factor is quite important in that first, Alright. So replication factor means that each block is copied those many times onto other node. Replication doesn't happen on the same machine. It doesn't make sense to replicate a block onto the same machine. Now, since each block will have three copies, it would look like it's a wastage of space. But the disk as such is quite cheap. Okay, so it is okay to have redundancy rather than a data loss. If a particular data node fails, it which means that all the blocks that were stored on that data node are lost, and hence those need to be regenerated. To regenerate it, it will name node will inform the other node saying whosoever had these blocks, please start replicated onto this machine, and so on. And that will ensure the system is up and running without our interruptions. Okay. Now, HDFS is not there is no bottleneck in HDFS. Although in the standard server client mechanism, this is how we generally cause the bottleneck. You can see that in general systems, you will imagine that there will be something called name node and every traffic will be going through that. No. The actual architecture looks like this. The user goes to name node, means user queries the name node and says, hey, I'm looking for this file. Name node, instead of taking the load onto itself, talking to this data node, that data node, reading the data, giving back to the user, it it basically tells the user, you go to this particular data node all by yourself and talk to that data node, and then come back. Okay, so that is the idea behind name node. So name node tries to keep itself absolutely free. It keeps on redirecting rather than passing the data through itself. Okay, because there will be multiple kind of blocks. Okay, if there is one user came to name node and name node got busy in serving the data, another node will come and ask the data, and the name node will become the bottleneck. Name node will make it impossible to perform, right? Therefore, the architecture is such that name node only informs the user back what to do. Name node does not do anything per se. So here the user could be yourself, but there'll be a command line which user will use. It could be a driver. Okay. So a user will use a command line or a driver, and that driver will be talking to name node, and name node will be telling in response that hey, you go to that machine, and then driver will follow. Apu's question is there any specific pattern for replication? Yes, there is a specific pattern. Generally, whenever you are pushing the data to the data node, one copy is very close to the user who is uploading the data, and other two copies are on different tracks altogether. That strategy has been changing for quite some time. It is something like redirect. You are right, Samant. It is something like redirect. Sounds good to you? Now let's have a little bit of another view of how the things look like. So there is name node, these are the data nodes, and client is writing the blocks onto data nodes. Okay, so write or read operations directly happen on the data node, and name node is just updated when the process is finished. So let's have a look at the diagram. This is the anatomy of the file, right? Yes. So the HDFS client user, as in you yourself, is going to use something called HDFS client. HDFS client is going to talk to first the name node. Okay. It will, when it tries to write any file, it will talk to the name node and will say, hey, I'm interested in creating this file. Name node will make a note of it in the index. Then the next step would be to start writing the data on the node which is very closest to the client. So it will start writing to the data node, and the data node will start replicating the data to another node at the same time. Okay. So another two data nodes are being written at the same time. You can see that. And once that is done, once this whole process finishes, the access to the data nodes is finished, then it will go back to name node telling it that I'm done with the writes. Okay. And remember, when HDFS was trying to write to name node told that why don't you go to these data nodes and write your these many blocks onto that data nodes. Okay. Closest data node, as in the generally on the same machine from which you are pushing the data. Okay. On the same machine from which you are pushing the data. This is clear to you? The anatomy is clear to you? Yes. Yes, this is for replication purpose. The moment you start, right? So Karthik's question is, are three nodes for replication purposes? Yes, that's correct. So you write to one node, the replication starts happening to other nodes. Yes, the name node suggests the node names, the data node names on which it has to go and store. Because name node is the one who is tracking which servers are free, which servers are busy, which one has space, which one does not have. Okay, great. Any other questions? Very brilliant questions. All right. So, and the anatomy of reading a file is very, very similar to writing the file. HDFS client, meaning the command line or the driver which you are running, will go to the name node. All right. So Pradeep's question is great. What happens when more than one client tries to write, or a huge number of clients try to write? Good. Good. So what happens when they try to write? In case they are trying to write different set of files, then name node will keep on making notes of all of those and keep on handing over them the access to the data nodes, and where the client can go to the data nodes and start writing, right? But if the all the clients are trying to write to the same file, then it will keep them blocked. If there are two clients, they have come simultaneously to name node and they want to create the same file. So one of them will get an error saying this file already exists. Appu's question is client node also have a layer of HDFS? Yes. So from where you're pushing the data, you generally have a client installed on that machine also. Okay. Wherever your data is lying, you generally install a client also there. Okay. So Poojan's question is that what if there are many clients connecting which want to write the data, and all this will talk to name node? Will this cause a performance overhead? It definitely causes performance overhead. Okay. Reason being that name node is fairly singular. Okay. But good news is that there will be only a single interaction of each of them with name node that will last only fraction of seconds. Why? Because name node will immediately read from RAM and give out the indexes and then move on. Okay. It would not wait for the client to for further instructions. All right. Good. Now, what does name node contains as metadata? Metadata is data over data, and the kind of data it stores is, one is the metadata in the memory. The entire data is in the memory. Entire data is in what are the folders, what is the replication factor, and so on. Then there is another set of data which is on the disk. Okay, which is keep on moving the data onto the disk. Now, the other kind of metadata is the list of files, the folder names, and the size of files, the number of replications, the block size of each files. Okay. And so all of that is stored as part of metadata. And while the transaction log is moved to the disk. Now, can we have replication of name node also? That is Apu's question. Answer is yes. And Poojan's question is, how are these multiple requests to name node will be responded? Right, right. So, I mean, name node keeps track of the memory allocations by itself and then it responds. Okay. All right, all right. Yeah. Data nodes will take care of the replications also. Name node just informs the two data nodes saying, hey, can you copy the data from one place to another? And then they will get busy. All right. So, Apu, was I able to answer your question? Not yet. Okay. I'll answer your question about backup immediately. Okay. So, Samantha, was I able to answer your question? Okay. Here it is sort of the structure you are asking about this one, right? Here it shows that a file is split into multiple parts. Part 0 is stored here, and it also contains the metadata as how many replicas have been created for this part 0 and what are the locations of blocks. Okay. Okay. So it shows that 1 comma 3 means this part is copied to data node 1 and data node 3 and so on. Okay. Instead of 1 2 3, it will be the domain name of the data node. Right. Okay, so it's the respective location on the disk or on the network. All right. Now the next question which arises is, what happens when name node goes down? Okay, so there is a philosophy called backup name node and secondary name node. There used to be something called a secondary name node, and that secondary name node used to take the backup of all the transactions which are lying in the disk. Okay, so every time name node goes down, you generally go to the secondary name node and recover your secondary name node from transaction logs, and then you start the secondary name node as the name node. Okay, the other way is by the use of something called backup name node, secondary name node and backup name node. So secondary name node, in secondary name node you have to do a lot of manual intervention to bring back the name node, while the backup name node is sort of always ready to become the the name node. Okay, so the backup name node, as and when things are happening across the network, every data node keeps pushing one copy of the changes to name node and other copy to backup name node. This ensures the data node uh, this ensure that all the data nodes keep on pushing all the information to the backup name node as well as name node. Similarly, name node also keeps on informing backup name node that hey, this file has been added, this file has been created, this file has been deleted, and so on. Okay, so name node always have a backup ready called backup name node, and the moment a name node goes down, you bring the backup name node immediately back to the life. Okay, so this is not HA. Okay, meaning it does not, the backup name node does not immediately take the place of name node. It still takes a little bit of manual intervention. Little bit as in you'll have to just mark it that this is my name node. Okay, it'll take maybe 1 minute. Senthil's question is, how often name node and secondary name node handle data update between these? Okay, so generally the data update happen quite frequently. Okay, the only downside is with respect to the transaction logs. Okay, those are generally little slower. All right, now let's move on. Senthil, was he able to answer your question? All right, now let's have a look at the other components in the Hadoop ecosystem. As I said, that Hadoop is basically an umbrella term and it contains multiple projects under the umbrella. Okay, so the first and foremost was HDFS, which we just talked about. Above that is HBase, a database which basically store its data onto HDFS, and it HBase is more like a data store, not a database. HBase is a NoSQL database, meaning it's a distributed database. NoSQL database is essentially a distributed database in that any data you push to a NoSQL database goes to multiple computers. There are multiple kind of NoSQL database, and there are multiple examples, say MongoDB, Cassandra, and CouchDB, and there are many examples of NoSQL databases. The common property of NoSQL databases is again the distributed databases. Okay, all of the NoSQL databases are distributed databases, meaning they utilize multiple computers at the same time, to solve your problem, right? So HBase is one such example of NoSQL database. HBase is great when you have to edit files because HDFS is not great for editing records. HBase is great for editing records. In case of HDFS, just like your file system, if you have to edit few records, it will be like rewriting the whole file. Okay. So although HBase utilizes HDFS for the storage of data. So HBase stores its data onto HDFS. The data files, the database files, it always pushes it to HDFS. Now, when you have to do the computation in a distributed architecture, you will have to utilize multiple machines, all right? And you can also utilize your distribution of data. Rather than taking your computation, rather than taking your data to the computation, you take the computation to the data. That is the role of yarn. Yarn is the architecture which makes it possible to execute any code onto multiple machines. Yarn is the architecture which makes it possible to run your code, your instructions onto multiple machines. Right? On top of Yarn, you have MapReduce and you have Spark. MapReduce as well as Spark both are sort of a paradigm. They utilize Yarn to execute their instructions. After that, there is something called Hive. So every time you have to churn the data, you generally used to end up writing MapReduce phases, and that was quite time consuming on developers' part. Instead of writing the code for each and every query on the data that would get executed across the cluster, people invented something called Hive, where your SQL query automatically gets converted into a distributed map and reduce, which gets distributed across the cluster and you get the answer. Okay, Krishnamurthy's question is, HBase organizes data of HDFS. That is Karthik's question. Answer is no. HBase is just another database when you want to do the record by manipulation. When you have the structured data and you want to do the record wise manipulation, then you will use HBase. HBase just uses HDFS. Just like your Microsoft SQL stores its data onto the normal file system, HBase stores its data onto HDFS. Shrikant's question is, do we maintain separate machine for HBase or do we use the same machines where we have HDFS? So you generally use the same machine and it is completely up to you to manage the capacity. Okay. So Hive queries, question is Hive queries is Karthik's question is, so Hive queries are on HBase or HDFS? Answer is both. Using Hive, you can churn the data from the tables of HBase as well as you can churn the data from HDFS, the files. Both you can do that using Hive as well as Pig. Now, what is Pig? Pig is exactly like Hive, just that a little bit faster. It's a new kind of a language which has been designed from bottom up because few researchers realized that SQL was not really designed for distributed computing. Okay, SQL was not designed for distributed computing. Therefore, Few researchers invented pig Latin to make it really, really fast to churn the data. So that is pig Latin. Now, there is something called Mahat. Mahat is basically a collection of libraries which runs on MapReduce and Yarn and other distributed computing environment. So Mahat makes it possible to make the magic. Okay. So if you want to do the recommendations, for example, say you are suddenly given an assignment of doing recommendations, you can actually just go to Mahat, pick up one of the command line, and then run the recommendation immediately by providing it some data. And and immediately you will get, I mean, Mahat will have all the collection of the libraries. Mahat has the all the algorithms in place. Okay. So you don't have to invent a machine learning mostly. All you do is tune it, tune most of the algorithms to your circumstances. Okay. So Mahat you can think of as a nice library provided to you which you can utilize instead of inventing your own recommendation algorithms. Okay. Please one example to use Hive, HBase and HDFS. Okay. Say you want to store your videos, okay, video files, so that you can analyze them. You will push all of the videos to HDFS. But see, you have a huge Twitter data and you want to process it again and again. You will first put the Twitter data onto HDFS, then use few commands to import the data into HDFS so that you can keep on modifying and altering it. Okay. And then whenever you want to churn, you will use your Hive to churn the data. Do the sentiment analysis will be done by SQL, Hive, or maybe Pig. Okay. So Pig and Hive are contenders. In case you are comfortable with SQL and do not incline to learn a new language, Hive is good enough for you. Okay. Now, so HBase is for the cases when you do want to do a record wise manipulation. HBase, sorry, HBase is great when you want to do the record wise manipulation of the data, just like any database. Files are great when you don't want to, when you just want to push the data, raw storage. You don't know how to, what are you going to do with the files? Okay. And using Hive, you can churn the data whether it's lying in HDFS or HBase. Okay. All right. Now, so we talked about Hive, we talked about Pigletin, we talked about Mahat. Now, there is something called Flume and Scoop. In case you want to push a lot of unstructured data onto HDFS, you will use Flume. If you want to move the data from your traditional databases, if you have a lot of data lying in your SQL database, you can use Scoop. Okay. Also, once you have finished the sentiment analysis in your HBase, you can use Scoop to move the data from HBase to MySQL, from where your website will display the data using PHP. Okay. So Scoop basically makes it possible to move the data back and forth from structured sources onto HDFS and to HBase. Okay. So we'll be talking all of these components, plus we'll be talking about Zookeeper in all these 11 sessions which are coming up. Okay, so the question is, Karthik's question is, why is there a overlap between HBase and MapReduce? So HBase does not provide you a sophisticated query language, but HBase's library provides you a way to use MapReduce and Yarn on top of HBase so that you can do the computation on top of a big table. If imagine you have a table containing a billion rows in HBase and you want to do some computation in a distributed fashion, that can be done using the same MapReduce and Yarn. That is why there is an overlap, right? Are you with me? Are you guys with me? Great, great. So we have Flume, we have Scoop. These guys are importing data into HDFS and HBase, and then there is HBase, which basically makes it possible to do the record-wise manipulation just like any other database does. And you have a compute engine which makes it possible to execute any logic on top of data. The main tendency is to take the code to the data rather than bringing data to the code. Okay. Now, and this yarn is being utilized in the form of MapReduce. You always talk in terms of MapReduce or in terms of Spark. You talk to yarn via Spark. You write your program in Spark and then hand it over to yarn for the execution, and so on. Now, in any project, let me explain to you. Flume and Scoop both are tools. Okay, all of these are actually tools. So yeah. These are basically for importing and exporting data from traditional sources. Now imagine this. You are building a great movie recommendation system. So first, what other things are you going to do? You will use Flume. You will use Flume to import data from your traditional source onto HDFS. Once you have done that, next step would be to write a Hive query or a Pig query to churn the data. And in case there is something which is not possible using Pig, Latin or Hive, you also write your MapReduce logic to do the processing in your Java program. Okay. Now, after you have done these three things, the next step would be to use the Mahout recommender to basically Mahout recommender will take three column input as in this movie, a rating, and the user. These three columns, and then it'll run on that. And whatever output is generated, you will have to move it from your HDFS to your standard MySQL from where your website will display the data. Now, there are so many steps. There are so many steps. You cannot keep on doing it manually, and this has to be done every second day, right? That is where your workflow like Oozie comes into play. Okay, that's where your workflow like Oozie comes into play. All right. So Oozie basically just like, have you guys used Apache Ant or Maven or Make? Samant has used, Apurv has used Maven. Yeah, build tool. Yeah, Karthik has used. Okay, so probably Karthik has also used because he knows that Apache Ant is a build tool. Okay, Rafe has not used. So good, good. So when you're using any of these tools, you basically define a chain of processes. That kind of work for Hadoop is done using Oozie. You basically tie all these jobs together: Scoop job, Flume job, HDFS, uh, you know, uh, Hive job, and all of these things together, and then the Oozie keeps on running it every day or on demand. Okay, and you interact with HDFS or any of these components either using command line, using the Java or Python or your own programming language, or you interact with this using a tool called Hue, which is a web-based interface. Okay, so Zookeeper, what exactly is Zookeeper? Thank you, Tej, for reminding that. A zookeeper is a system which makes it possible to do the high availability and consistency. What does it mean? Just like on every traffic light, you need a traffic policeman and a traffic light, any signal. When there are multiple people coming across and going, you need a central system to guide all of them. And that is what the zookeeper does. Okay, so when you are building your cluster, you will have multiple instances of, say, HBase. All of these multiple instances of HBase will be talking to each other using zookeeper. So zookeeper will act like a middle party. Everybody informs zookeeper, and everybody asks information from zookeeper. So zookeeper basically makes it possible to coordinate by various services. And therefore it is important to learn zookeeper in case you are building any kind of distributed application. We can use cron job. Apu's question is, can't we use cron job instead of Uzi? Yes, you can use a cron job, but Uzi also provides you time wise triggering of job or data change triggering of job. So in case a particular table has changed, the Uzi will launch the job. Okay. You can define all of those. All right. So Tej, was I able to answer your question? So name node is a singular entity, is not highly available. Okay. Zookeeper is again a collection of nodes which keep on automatically making somebody a leader so that others can talk to it. Okay. So basically, whenever you need a very high throughput system which can make the coordination possible between various machines, then you use Zookeeper. Zookeeper does not depend on HDFS or any system. Zookeeper is sort of an independent entity itself. Okay. Zookeeper is used by HBase, and NameNode is also planning to use Zookeeper. All right. No. NameNode's duty is to provide you the index of HDFS, and Zookeeper is a public service, is a very simple service. So people, these all components actually use Zookeeper. Okay. So you will get a more detail into this picture once we go into this. So Zookeeper is a general purpose service, while NameNode is specific to HDFS. All right. All right. So but there are many questions like what is Cloud Labs and all. So what we have basically done is set up a cluster for you guys with all of these components. Okay. So all of these components are installed onto our Cloud Labs. You can talk to the Cloud Labs, and then you can you can do SSH onto Cloud Labs, or you can open the Cloud Labs servers from your browsers. This is important because as we talked about all of these technologies, the biggest difference is that these technologies are for distributed computing. Okay, these technologies are for distributed computing. Therefore, it is important to have an online cluster of servers. You should know how does it happen in real world. Okay, therefore that is what the motivation behind setting up Cloud Labs. Okay, and you can access our Cloud Labs from anywhere in the world. Okay. And generally, when you want to install a virtual machine on your laptop, it requires a huge amount of RAM, and it needs a high-end configuration. That is not true in case of our Cloud Labs. In Cloud Labs, even if you have a simple small l- laptop, you can start using it. Even if you have a tablet, you can start using our Cloud Labs. Okay. Now, Those who have signed up for our course and are attending this, please go through our the entry point of our cloud labs. This is the admin interface. This is the admin interface. It's logging in. All right. So this shows the admin status. Now you can see here the HBase is down. So let me try to store. Okay, I'm starting it. We had shut down the HBase recently purposefully. So it shows. Okay. So the login is not provided to you yet. Okay, only the candidates who have signed up will have the login password in the learning management system. And in case you want to interact with HDFS, you can use Hue. Hue makes it possible. This is Ambari. Ambari makes it possible to control all the services, and Hue makes it possible to interact with services. For example, if you want to do you want to see the files in HDFS, it is like this. Okay. So for every student, they have the folder structure. Okay. There are too many files actually. Yeah. So that's okay. And here you can see what's the status of various things. So if you want to see what's going on with HDFS, you can go here. It shows that 4 out of 4 data nodes are alive. Okay. And there is name node size is this much, and so on. Okay. Now also you can connect to our system. You other than Ambari and Hue, you can SSH to our system and then start working on it. Now also go through your my courses. There will be, if you log in, you will see my courses if you're signed up for any course, and you can you know set up Hadoop environment based on the virtual machine also. In case you really want to set up your virtual machine, you can do that here. Okay. Also finish the quiz based on today's session. Some of the questions will be related to the map reduce and yarn. Don't touch those questions. Rest is okay. Okay. And yeah. So we'll not learn Apache Tez yet. Okay. We'll not learn Apache Tez yet in this one. Okay. All right. So for full course, if you want to attend the full course, those who have not signed up, you can sign up from our website itself. And the next class, second class onwards, you can attend. There are two classes which are starting. One in the morning, 22 February onwards. On 21st February, this first session will be repeated again, and there's another course starting on 1st March, which is in the evening. So you can choose whichever you want and sign up for the course. In case this first session is sufficient for you, then it's good enough. In case you want to, you know, learn all about these components and the philosophy behind the distributed computing, you can sign up for the course. Okay. The course charges are 18,747. Okay, and this include clusters for hands-on experiment. Okay. Alright. So that's pretty much about today's session. So feel free to get in touch in case you want to go for the future classes. There are 10 more classes. Okay, and the our learning management system looks something like this. If you go to my courses, in my courses, so let's take one particular course. So these are the courses. It shows you the detail of various dates and then all the documents which are there. All right. All right. So that's pretty much. If you have any other questions, please feel free to come to our forum. We we are open to everyone. You can ask any questions. We'll try our best to answer the questions. And then, okay, yeah, we'll be sharing the session recording with everyone. So you can interact here, as well as our main website is this one. So you can have a look at that. All right. Session recordings will be shared with everybody. Okay. After this, it will take around 3 to 4 hours to get the session recording done, because it takes some time to convert and then upload to YouTube. All right. Because these are public sessions, we generally make it public, all the recordings. All right. So if you have any questions, feel free to get in touch with us either here, okay, or you can go to our forum as well. Okay. All right. Thank you very much. Have a good day. All right. If you have any questions, please feel free to. Okay. Thank you, Neeta. Thank you, Vidyanand. Thank you, Shrikant. I'm happy that you found it a great session. And thank you, Poojan. I'm also, I mean, happy that you liked the session. Okay. Thank you, Rafe. Thank you, Raghvendra. All right. I hope you liked the session, and feel free to inform your friends who are interested in the sessions in learning big data. Okay. Colleague, your friends, whosoever want to learn that. All right. So our intention is to basically, help people learning big data and Hadoop as much as we can. Good. Thank you, Karthik. Thank you, Jay. Thank you, Saman. Thank you, Senthil. Thank you, Poojan. Thank you, Shrikant. And stay connected. Keep asking questions on our forum, or in case you have a question directly, you can reach us at knowbigdata.com, and feel free to ask questions. And that's pretty much. So yeah, I'll send you the presentation as well as the recording for this session. Okay. Yeah, you will have you. Yeah, you can go ahead and enroll for the session from the website. All right, Raghavendra. Yeah, you can go ahead and enroll for further sessions. Great. All right. Thank you very much and have a great day. All the sessions will be online. That's right. Because what we realized is when we were giving trainings, what we realized was that candidates who attended our offline session were not performing great, while candidates who were attending our online sessions, their performance was marvelous. Okay. I don't know the reasoning, but this is what we observed from our few sessions. The performance was 2x times better in online sessions. So that is the reason. All right. So we stopped giving offline sessions. We have moved to this kind of format. All right. Any other questions to me? Feel free to ask me questions and either drop me an email or drop your query on our forum. All right. Thank you very much and have a good day. Bye. I'm hanging up now.